Hello, my name is Sandos. I'm doing assignment number 5, problem 28, and I'm with Team Phosphorus. The question I'm doing asks to calculate the Arrhenius parameters for the reaction. We've got two nitric oxides and that reacts with a molecule of oxygen and results in two nitrates as the product. They have given us different rates at different temperatures. We've got the temperature in Kelvin and K, which is the rate constant. So the main effect of the temperature on the rate of a chemical reaction comes through the specific rate constant, K. The effect of temperature on K is described by the Arrhenius law. So the Arrhenius law says that K is equal to A to the power of negative EA over RT. K is going to be our rate constant and A is going to be our pre-exponential factor, which is also equal to the number of collisions at the atomic level. And then we've got negative EA, which is our activation energy, or the energy barrier that must be surmounted in order to form our products. And then over R, which is our gas constant, which is also equal to 8.314 joules per mole times Kelvin. And then last, we've got our temperature in Kelvin. So our Arrhenius parameters are going to be our A and our EA, which is our pre-exponential factor and our activation energy. So that we may predict the correct rate constant at any given temperature. The determination of these two factors are made graphically, and in order to do that, we know that this is a first order reaction, so we're going to take the ln of that equation and we're going to get ln of K is equal to ln of A minus EA over RT. And then if we look closely, we know that this is going to be a linear equation, so we're going to rearrange it so it's easier to see. So once we arrange it, we're going to get ln of K is equal to negative EA over RT plus ln of A. So now we see that ln of K is going to be our Y, and then negative EA over R is going to be our M, which is our slope, and then 1 over T is going to be X, plus our intercept, which is going to be ln of A. So from this, we realize that the dependent variable is Y, which is our ln of K, and our independent variable is X, which is our 1 over T. Now we can graph it, and once we do that, we're going to graph ln of K on our y-axis and our 1 over T on our x-axis to get a straight line. And then from that straight line, we're going to get the equation of that line. And from that equation, we see that the slope is going to be 609. So the equation is going to be 609x plus 20.6. We know that our slope is going to be negative EA over R from our equation, negative EA over R, and we're trying to solve for EA. So what we do is we plug in our slope and then EA over R, and we know R is our gas constant, which is a given, 8.314 joules per mole times Kelvin. So we're going to rearrange that and solve for EA. And then we're going to get that EA is going to equal to negative 5,036 joules per mole, and then that's going to equal to negative 5.063 kilojoules per mole. So that's going to be our activation energy. Now next we need to find our pre-exponential factor, and we're going to do the same thing. So from our equation, we know that our exponential factor A, ln of our exponential factor is going to equal B. And we know B from the equation of the line is 20.6. So ln of A is going to equal to 20.6, and we need to solve for A, so we rearrange that and we get that A is equal to the 20.6, and that's going to equal 8.84 times 10 to the 8th. And that's going to be our activation energy. So now we've solved for our parameters of the Arrhenius equation, which is our pre-exponential factor and our activation energy.